Okay, so we're going to pick up on question number 11. You don't actually have to do all of this question. A lot of it isn't is stuff that we haven't covered yet. Let me move this. But you can do the first part of it. So reaction number 1, you're just given an alkene and you're told you're reacting with hydrogen bromide. Now, we've seen doing these reactions before. Hopefully we remember that you can get the bromine adding... where's my pen? When you add hydrogen bromide across a double bond, the bromine can add here, or the bromine could add here, and you get a major and a minor product. You need to look at the final product that you're given down here, and you'll see that you have got an OH group on this carbon. That tells me that the bromine is after adding to this carbon, okay? Not this carbon down here. It must add to this carbon in order for us to get this final product. So when I'm drawing my product here, I'm going to draw out my, I'm going to draw my C6H5. I'm going to lose my double bond. And I'm going to add my bromine to this carbon and my hydrogen to this carbon, okay? That's the only product that I want. There's no point showing it on the other carbon because it's not consistent with what you get below. This reaction, we've never done it before. Okay, it's year 13 stuff, but basically that NH3 is going to substitute in for the bromine and you're going to get an NH2, but I'm not going to bother with that one. This one down here, we can do, okay? You've got your haloalkane and you're reacting it with sodium hydroxide, and what you're going to get is you are going to get a substitution reaction and you're going to lose that bromine and you're going to replace it with an OH. Also, it's worth noting, okay, sodium hydroxide is a base and you have got a carboxylic acid. So when you add the sodium hydroxide, you are going to lose the hydrogen from your carboxylic acid, okay? This hydrogen here is your acidic hydrogen on your carboxylic acid. You will lose it when you react it with a base and you're going to end up with O-. That's why they have this final step here where they add the H+ to restore your carboxylic acid, okay? If you were here and you weren't really sure where you were going, just look what your final product is. The only difference from what I've drawn and what we've got down here is you've got an OH instead of a bromine. You're reacting it with NaOH, so it's just going to be a substitution. That OH bonding to the carbon and that carbon-bromine bond breaking, okay? The last little step here is because you're adding a base to an acid, you're going to lose the acidic hydrogen. I'm not going to go through this mechanism because we've done it loads and loads of times before, but do ask me if you get stuck. This next one, okay, you're asked for an addition polymer and a condensation. We haven't done condensation yet, so I'm just going to do the addition one. When I'm doing an addition polymer, I am focused on my double bond, okay? I want to make that the kind of center. And when I am joining these molecules together, I'm going to be joining them by the 2 carbons involved in the double bond. In order for this to happen, that double bond is going to have to break. So I'm going to draw these 2 carbons, these 2 that I've outlined here, I've drawn here, okay? And then I just need to put the substituents on each carbon. So this carbon is bonded to a hydrogen. It's also bonded to this COOH group. This carbon here is also bonded to a hydrogen, and then it's bonded to a phenol ring, which I'm going to abbreviate as PH because I'm lazy, but you could draw out the benzene ring with the OH, okay? Because it's a polymer, you have to draw extended bond lines, okay? It's going to continue in both directions, and on the mark scheme, they don't require brackets or an N, but I'm going to include the brackets and an N because often they do require, okay? So that's what your polymer should look like. You don't need to do condensation. I'm going to skim through these ones as well. But if you want me to go through them, please let me know afterwards. You obviously do not need to be able to do this. Sorry, this is number 13C. It talks about H&MR spectroscopy. We have not done that yet. I'm going to do this one. I know it looks different to what we've done before, but it's actually quite straightforward if you understand what's going on in reaction mechanisms, which hopefully you all do. They ask you in step 1 to add curly arrows to show how your nucleophile reacts with this diester to form the intermediate in the box, okay? So I know that this is a nucleophile, so I'm going to be starting my arrow from my nucleophile. I just need to see what I'm going to attack. And we've got lots and lots of different functional groups here, and there are plenty of options. But if we look at the intermediate, you will see that this carbon here has lost one of its hydrogens, which means that hydrogen must have been taken. So what's going to happen is your nucleophile here, your methoxide ion, it's going to, starting your arrow at the negative charge, it's going to attack that carbon. And when it does, that carbon-hydrogen bond is going to break, and both of those electrons are going to go onto the carbon, which is what gives the carbon the negative charge. So you're getting that mark for 2 arrows, one going from the negative charge to the hydrogen, and one from the middle of that carbon-hydrogen bond onto the carbon, which gives the carbon the negative charge. Then they ask you at the end for an organic product, and I know that this is a far more complicated molecule than what we have looked at, but they're asking you to react it with a haloalkane, C2H5Br, which if I draw that out in full, it's going to look like this, CH3 with the CH2 and a bromine. Okay, we know that every single time we are reacting a haloalkane with something, that the carbon bonded to the halogen is delta positive and the carbon's going to be attacked. So you know it's going to act as the electrophile. You know that carbon's going to be attacked. You just need to look at this and ask yourself what's going to attack it. Okay, it's pretty obvious. You've got a carbon with a negative charge. That's going to be your nucleophile. So this carbon here with the negative charge is going to attack this carbon here, and then that carbon-bromine bond is going to break. You're not required for a mechanism, but again, it can help you see what new bond is going to form. So you've got the negative carbon, it's going to attack something positive on this molecule. When I draw it out, I can identify the carbon bonded to the bromine is what's going to be delta positive. So you're going to form a new bond, and you're going to draw out this whole molecule again, because none of this is going to have reacted. Your carbon's still there, you've got all of this and all of this. You've got one hydrogen intact, and now this carbon is bonded to this carbon, which is no longer bonded to the bromine, but it's still bonded to 2 hydrogens and a CH3 group. Okay, so if you got all that done, it was 3 marks, so well done. I'm going to scroll. This is just heating an alkene. Heating or forming an alkene, so you're heating it with steam and an acid catalyst. I'm going to scroll through all of this as well, just so the video doesn't get ridiculously long, but I'm hoping this will be okay. 17, I know this is a tick box, but I just want to explain it. You're going in step 1 from an alkene, and then you're losing that double bond. So if I'm losing that double bond, I know it's an addition reaction. Okay, I'm going from 2 reactions, and I'm adding them together to form one product. Step 1, they only give you addition as an option, but is it electrophilic or is it nucleophilic? Okay, to answer that question, when you write out this mechanism, it's the double bond is going to reach out and attack that hydrogen. Hydrogen, in this case, is an electrophile. So you're adding an electrophile to the double bond. So it's going to be electrophilic addition. Okay, if you're adding an electrophile, it's electrophilic addition. And then in the next step, you see you are swapping the bromine for an OH. So I know it's going to be a substitution reaction. To identify which type of substitution, you need to look at what you're substituting in. So you're substituting in an OH minus for a bromine. OH minus acts as a nucleophile, so you're subbing in a nucleophile, okay? Which means this one here is going to be your answer. B is going to be your answer. Scroll. 19. Oh, I did want to look at this one, didn't I? Yes, I did. You're starting off with So you are starting off with compound C, and when you heat it, you end up with an alkene. Okay, so if we have an alcohol and you heat it with an acid, you end up with an alkene. So I know I must have an alcohol here. So I'm going to draw out the general structure without an alkene. Okay, I'm going to draw out everything else the same, but I'm not going to include that alkene because I know I've just formed that alkene because I've dehydrated my alcohol. So I must have a hydrogen on one of these carbons and an OH on the other one. Okay, once I've got that alcohol, I heat it, I dehydrate it, I get my alkene, but I need to decide where my OH is going to go and where my hydrogen is going to go. If I put my OH on this carbon, I have formed a primary alcohol. Okay, if I've got a primary alcohol and I heat it with my acidified dichromate, I am going to oxidize it. And it tells me here that I get no reaction whatsoever with my alcohol and my acidified potassium dichromate. That tells me that this must be a tertiary alcohol, which means I've got to put the OH group on this carbon and the hydrogen on this carbon. This gives me a tertiary alcohol. Tertiary because the carbon is bonded to 1, 2, 3 carbons. It cannot be oxidized, which is why I get no reaction. But because it's an alcohol, when you heat it with an acid, you lose the OH, you lose hydrogen from the neighboring carbon, and you end up with an alkene. Okay, so that's one of my answers. And then I need to draw polymerization. I've got an alkene. It's going to be addition polymerization. It's a simple one. I'm drawing out these 2 carbons of my double bond at the center. I'm showing what they are attached to. I am not including my double bond because I need to draw extended bond lines, and I'm going to put in my bracket and I'm going to put in my N. So that's number 19. 20. I'm just going to flick through. Oh, actually, this one I'm going to do for you because it originally looks really difficult and it's actually not that bad. Write an equation for this reaction. Okay, so you're saying that you are preparing 2,2-dimethyl-propan-1-ol. So I'm just going to draw that from the start. Propan-1-ol. I've got 3 carbons and I've got an OH and it's 2,2. So it means I've got 2 methyl groups, okay? And can be prepared by hydrolysis of a chloroalkane with aqueous sodium hydroxide. So I've got a chloroalkane. I react it with sodium hydroxide and I am forming this. And they want to know what is that chloroalkane, okay? If I want to form this from a chloroalkane, okay, everything is going to be the same apart from instead of that OH, I'm going to have a chlorine. Okay, if I've got a chlorine there, react it with NaOH, the OH comes in, kicks off the chlorine, and I end up with this. I'm also going to end up with NaCl. Okay, so that's your final product. 21 should be okay. 22 should be okay. That's just a mechanism. 23. 24. If you just draw it out, even if you just draw the first one, if I draw the first one, pent and 3-ol, okay, if I if I react this with an acid catalyst, I'm going to form an alkene, and I can form this alkene, or I can form this alkene, but they're both exactly the same because you'll number from the other side. Is this alkene, does it have EZ stereoisomers? Yes, it does, because this carbon is bonded to a hydrogen and a CH3, so it's bonded to 2 different groups. This carbon is bonded to a hydrogen and a CH2, CH3. So my very first one in my list is going to fulfill the criteria. If you look at the rest of them, you will work out that they don't. Question 25, you absolutely do not have to do. Sorry, that's like all year 13 stuff. So just ignore question 25 completely, and in the next video I will pick back up with question number 28.